Hi all, so today we are going to solve this question 3742. So in the question you are given an m cross n grid and where each cell contains one of the values either 0, 1 or 2. You are also given an integer k. You will start from the top left corner 0, 0 and want to reach the bottom right corner, this is m minus 1 and minus 1. And by moving only the right or down direction, so only in the two directions you can move. Each cell contributes a specific score and incurs associated cost according to their cell values. So if the cell value is 0, it adds 0 to your score and it costs 0. If it is 1, then it adds 1 to your score and it costs 1. If it is 2, it adds 2 to your score and costs 1. So you need to return the maximum score achievable without exceeding a total cost k, and you can return minus 1 if there is no valid path exists. You can reach the last cell, but if the total cost exceeds k, then the path is invalid. Okay, so you need to start from top left and you need to reach to the bottom right. So in the constraint, if you see, you are given also the initial value is 0, right? So you don't need to worry about the initial cost if you are at the position top left cell. So in this example, we are given this cell of m cross n. Let's say m is 3 and n is 4, right? So 3 cross 4 cell is there. So here you are initially at the 0, 0 position. From here you can either go to the down direction or go to the right direction. So there are two valid paths. One is this and the other one is this. So other can be valid path, but the maximum score that you would get is through these two paths only. And if you come to this position, then it means that you have already exhausted 1, 2, 3, cost 3, right? 3 units. So, and in the last cell, you have to exhaust one more unit of cost, right? So you cannot go to this down direction. From here, you can only go to the right and then down direction. So if we see this location, initially it is 0, 0, right? And the k value is 4. From here, you need to check once you go to the down direction, either you can go to the down or you can go to the right. Let's say we go to the down direction, then I would be 1 and j would be 0. So you need to check if the condition is failing. So when would our condition fail? Either if this location is going out of the bound, like your I is reaching m or j is reaching n, or if the cell value is greater than 0 and k you have already exhausted and it is 0. So if you check these two conditions, this is the fail condition. In this case, we would return directly the minimum value that will depict that we cannot move forward with this position. We can directly return this. If so, in this case, we can actually come to these two cells, right? So once we come here, the k value will be 3, right? Because we have to incur a cost of 1 unit here, also a 1 unit here. So here also the k value would be 3. So from here we can either go to the down direction or the right direction again, right? And for a given k, and if the positions are same so for this path also we are getting to the same location, right? So this is showing you one state of our method, and we are revisiting the state. So we can explore it in one and store it in some data, some data structure, and reuse this data structure for calculating this, because we don't need to go to all the child. So this is fairly simple DP problem, and we are going to memorize this recursive call here and use it here for this state, right? So let me walk you through the code. That is exactly what we are doing here. So in this code, this minimum will actually depict we cannot move further from one location and we cannot explore further. And this is the R and C, like number of rows and columns in the grid. The K cannot be, more than this, right? Otherwise, we would be taking some unnecessary uh, states that we might never need reach. So it should be the minimum of these two values. And we are creating a DP to get all the states that are possible for our recursive solution. Initializing all the states with a minimum value, like it is unvisited score, unvisited location, and we are initiating the call with the initial position as 0, 0. If there was some initial cost associated for the first position, then we would have added it here. So we are not adding because in our constraint, it is given that the initial position value would always be 0. And from here, when we explore, come to a new location, then we will first check whether if it is going out of bound or not. So this is the fail condition that we wrote. And also the fail condition is like if the cell value is more than 0 and we have already exhausted our k. So in both the cases, we would simply return the minimum, which would depict we are not moving forward, right? If we reach to the target cell, that is the bottom right cell, then we can directly return the score of the current cell, because we don't need to check, like, because in this position we are already checking, we can move forward to this location, right? So we can simply return this score here if it is 0, 1 or 2, because we can ultimately reach to this cell. Here we are using the memoization thing, like reusing it basically. Like if it is in memory, like if we have seen this state, then we don't need to explore it again. We will directly return it. And then if the value is the cell value is more than 0, it means that we need to incur a cost unit 1, right? So 1 unit we are decrementing from the our current k value. And uh, if we try to explore the down value, then we increment I, and if we explore the right side value, right cell value, then we increment the j, and we add the current cell value to our score, right? And here we are adding the k value back if the grid is 0. If it is greater than 0, if it is greater than 0, then we would have decremented it, right? And that's what we have used in our recursive call. But once we come out of recursion to depict this state correctly, we need to increment it back, and we are memoizing this state into our this state data structure, and we are taking the maximum of both the exploration that we did in our recursive approach, right and down. So yeah, this is the solution. Hope you liked the video. See you in the next video. Thank you.